Hello, everybody. Hope you guys are doing great and you are happy and fresh. Let us talk about very important uh, topic that we know a little bit about collision. So today, what I am going to say, I'm going to talk about the different types of the collision. When you use the word collision, we know that collision is the bumps, crashes, impacts when two objects hit each other and a large force acts for a very short interval of time. When two objects collide, so we consider very important rule that was named as law of conservation of momentum, and that law of conservation of momentum says momentum of a system before collision is equal to momentum of the system after collision. So the first thing that I need to talk about the type of collision, that this type is named as elastic collision. First and foremost thing I would like to mention here, that elastic collision, the word elastic doesn't mean like the elastic stretchable here. Here elastic collision mean that it is a system in which the momentum of the system before is equal to momentum of the system, total momentum of the system before collision is total momentum after the collision. We say that law of conservation of momentum holds here. Second thing, kinetic energy of the system before collision is equal to kinetic energy of the whole system after the collision. So, we have to remember one thing, that law of conservation of momentum, law of conservation of momentum, and law of conservation of kinetic energy both hold mean uh, both are equal before and after the collision. On the other hand, we just say that whenever we have a colliding object uh, in which law of conservation of momentum hold, but law of conservation of energy does not hold. What does this mean? It means it's like our natural system in which we have a loss of energy. In the energy cannot be destroyed, but it can be converted from one form to another form. So in this scenario, what happened? So law of conservation of momentum holds. So law of conservation is true for momentum. Law of conservation of momentum is valid, but law of conservation of energy is not valid. Law of conservation of energy does not work here. Conservation of kinetic energy is not valid. So what happens is, we can say total momentum before collision will be equal to total momentum after collision. But on the other hand, kinetic energy before will not be equal to kinetic energy after. So if this situation prevails, so we can say energy is converted to some other forms. What are those other forms? Like, it can be converted into sound, it can be converted into light, it can be converted into potential energy, and etc. So you can say it is converted into sound, it is into light, into heat, into potential energy, etc. So this energy is being converted. So what we found here is very simple thing, that whenever we are concerned about uh, to differentiate between elastic and inelastic collision, so we have to remember that if momentum is conserved but kinetic energy is uh, lost, this is inelastic. If momentum and kinetic energy both are conserved, then it is elastic collision. So here in inelastic collision, if we have two object system, for example, we have two objects here in this scenario, and if this is the object with mass m1 that is moving toward another object uh, that is stationary with mass m2, its velocity is 0. So if after collision what happens, that first object with mass m1 has some velocity v1 final, and also the second object with mass m2 has some velocity, so they share some velocity, and still there is some kinetic energy lost. So kinetic energy before is not equal to kinetic energy after, so this will be considered as only inelastic because energy is lost, or simple inelastic. But if a system is like this, that both the object stick together, and when they stick together, so we can say their separated velocities are now converted into one final velocity vf. So this system in which they stick together, they move together after the collision, this will be called perfectly inelastic collision. So whenever we use the word perfectly inelastic, it means kinetic energy is still lost, but after collision the objects stick together. In a simple inelastic collision, objects are separating out after the collision, but their energy is lost, momentum is saved. So here, whole scenario can be summarized in this way, that a collision in which two objects hit, and after hitting they separate out, their momentum and kinetic energy is same, it is perfectly elastic. If two objects after collision are separating and still energy is lost, momentum is the same, so it is inelastic collision. But if they hit together and after hitting they are moving by sticking together, so if they stick together they move forward in this direction, so what will happen, we will say that this system is perfectly inelastic. So for a simple inelastic collision, we will use the equation that we usually use. What was that equation? We use law of conservation, that m1 v1 I before collision m2 v2 I will be equal to m1 v1 F plus m2 v2 F, because momentum is not changing, momentum is same. So we use in this case when it is simple inelastic collision. But when it is perfectly inelastic collision, we will change this scenario and we can say m1 v1 I plus m2 v2 I will be equal to m1 plus m2 into vf. Why? Because v1 I and v1 F and v2 F is simply now the same vf. So we can also say, if we are asked to find vf, we can use this scenario. If you are finding masses, it's okay, you can use it directly. But if they ask final momentum together, so you can say that vf will be m1 v1 I plus m2 v2 I over m1 plus m2. So this will be the situation that will give us a perfectly inelastic collision situation. So to understand it further, let me go to a very simple situation here that I try to show. There is a ball, white ball is going to hit with the red ball. Both are the same masses, so you can say this is moving with v1 I, whereas v2 I is 0, and after collision v1 F is 0 and v2 F is moving. So after collision they are separating out. So if I identify this, analyzing the system gives me that this is a case of, uh, if no energy lost, then it is perfectly elastic, and if energy is lost, this is inelastic, a simple inelastic consideration. So here we can just simply, the momentum of the white ball they consider is m1. That white ball changes from positive to 0, whereas the red ball changes from 0 to positive. On the other hand, during the collision, energy is conserved, and during the collision, momentum is also conserved. So we can say this is perfectly elastic collision. So this is elastic collision case. But if you say that there is somehow energy lost, so we can say that it will be simple inelastic collision. Here in this case, in two bumper cars, you can say when two bumper car hit, there is somehow there is loss of energy, so we will consider it as a simple inelastic. But what we will use for this case, we will use the equation m1v1i plus m2v2i is equal to m1v1f plus m2v2i. So total momentum of the system, either it is elastic or inelastic, it will remain the same before and after. And this is our decision. Now I would like to talk about inelastic collision example. For example, this is the girl that is moving, having a roller skater, and she is moving. She is a roller skater and moving toward a bag. What happened is, when she was approaching toward the bag uh, was having different mass, smaller, but she was moving. So what happened when she rushed toward the bag? Initial situation, you can say that, let's say this is the girl, and this girl has its own m1 v1I momentum. Bag is stationary with the momentum is zero, but I will just say m2 v2I. But when she is going and grabbing it upward, no, the total momentum change, and it will become m1 plus m2 into vf. So the total momentum here in this case, she will move forward, but it will become slower because the mass is now becoming a system, and it is a case of perfectly inelastic collision because both of them are sticking together. So to understand further, let us talk about another example, how we will solve the questions related to perfectly inelastic collision. Let's say we have the roller coaster 61 kilogram moving with 12 meter per second to the east picks up the bag. What is the final velocity of the person traveling with the basket? So first thing first, she was moving toward the bag. Bag was stationary. She was having a velocity. After the collision, she is going to pick up the bag. So bag and the girl is a system. So this case we analyze is perfectly in elastic collision. So when this is perfectly in elastic collision, I will use to find the final velocity. As I said, it is Vf is to find. For perfectly inelastic collision, I told you that we will use the equation. That equation is final velocity of the girl and bag will be equal to m1 v1I plus m2 v2I over m1 plus m2. So when you substitute the values, we will find the final velocity. M1 is 61 times 12 plus m2 is 5 times 0 over 61 plus 5. So this will be the final velocity of the girl and bag. I can find 61 times 12. It gives me 732, and the other side bag has no momentum, it's 0 over 66. So when I divide it by 66, I get is 11.09. So final velocity 11.0909 and so on, 09 bar meter per second. Here I need to mention one thing, that we have two significant figures, so I will prefer to write final velocity as 11 meter per second, and it is same forward direction. But we can see in this scenario that what happened is she was moving with 12, but after grabbing she is slowing down. This slow down doesn't mean that momentum is less, no, speed less, because mass was now from 61 to 66. So this is a very good example of perfectly inelastic collision. Let me go to another perfectly inelastic collision. In this problem, we have a 1500 kilogram car traveling with 15 meter per second. Let's say I have this car and this car is having mass m1. M1 is 1500 kilogram, and this car is moving with 15 meter per second. Let me consider that this direction which I put in the right is the south. Actually, you know that south is downward direction, but I consider that it is south. Collide with a truck. This is, let's say, the truck. Excuse me. This is the truck having mass that is three times more, 4,500 kilogram, and this truck is initially at rest. So we can say that its velocity v2I is equal to 0 meter per second. So this is system before they hit. After some time, what happened? The car and truck get stuck to each other. So this is the truck. This is the car. Car is going to hit the truck. When car is hitting the truck, it crashes. So this is the car and truck is one system. So this is after crash, after collision. So when they collide, what happened? What is their final momentum? They, because they are now one system, car is pushing it forward. So their final velocity, I will just say Vf. So from law of conservation of momentum, when we use for it perfectly inelastic case, because this is perfectly inelastic collision, two separate objects now sticking together. So here they stick together. So when they stick together, I will say that the final velocity Vf is equal to m1 v1I plus m2 v2 I over m1 plus m2. So I can just simply say Vf is equal to 1500 times 15 and plus 4500 times 0 over 1500 plus 4500. So this scenario, when I add them up, what I got, 1500 times 15 gives me 22,500 plus 0 over 6,000, because 1500 plus 4,000 I divided by 6,000. What I got 3.75. So Vf in three significant figure is 3.75, but in 2 I will change it to 3.8 meter per second, and it will still moving forward. Why it is moving forward? Because this one is a system and it still goes to the same direction what you have. So if they say the magnitude of the velocity, you will just simply say it is magnitude of the velocity is just 3.8 meter per second. But if they ask us to find uh, the total momentum and total this, so then you can write the direction. This also seems to me same. This one looks different. Let us talk about a 47.4 kilogram student run down a sidewalk, jump into horizontal speed, a 4.2 on a stationary skateboard. So this is the boy. Let's say this is the boy. It is running toward the stationary skateboard. So mass of the boy M1 is 47.4, and he going is running down the sidewalk and jump with the horizontal speed on a stationary. So he is moving with V1I, that is 4.2 meter per second. On the other hand, the skateboard, uh, I don't know its mass, but it is M2. I still don't know the mass of the skateboard, and this skateboard is V2I, that is stationary. Now, the student and skateboard move. The A part I'm going to talk about. The student and skateboard move together. So this is after the collision. Skateboard and the student is on the skateboard now. So this is a system that is stick together and it is moving with a common velocity Vf, that is equal to 3.95 meter per second. So we are asked to find mass of the skateboard. So I am going to do perfectly inelastic collision. We know that m1 v1I plus m2 v2I for perfectly inelastic collision will be m1 plus m2 vf. So substituting all the values, m1 v1I is 47.4 times 4.2, whereas V2 is 0. So V2I 0, I will put it 0. 47.4 plus unknown M2 into Vf is 3.95. So first I will try to do 47.4 times 4.2. I get is 199.08, 199.08 uh, is equal to 47.4 plus m2, and this 3.95 I divide on the other side. So when I divide it by 3.95, I got is 50.4. So here I got 50.4 is minus 47.4 is equal to m2. So when I subtract 47.4, I got exactly mass of skateboard is 3 kilogram. But I need three significant figure for the mass here written, and two significant figure for the speed, and three, so minimum is 2. So I can simply write 3.0 kilogram is the mass of the skateboard. So the second part of the same question is saying that you have to find how fast the student would have to run initially to have final speed 5. So if he want to have final speed 5, what would be the initial? So same rule I will use, m1 v1I plus m2 v2I is equal to m1 plus m2 vf. So here in this case we want v1I, so 47.4 v1I, because now I will just say what is initial velocity v1I plus m2 is 3 times uh, what was its velocity 0. So we can say it as 0 is equal to 47.4 plus 3 into 5. So this will be 50.4 times 3, and this will be 47.4 v1I. So I just multiply 50.4 times 3. I sorry, my mistake, this is not 3, this was speed of 5. 47.4 times 5, it gives me 237. So I can just say v1I is equal to 237, and 47.4 will be divided here, divided by 47.4. So the initial velocity of the first object, uh, it should be, I have 47.4. Let me confirm it. Sorry, my mistake. I think so. It was 50.4 times 5. Answer is 252. Sorry, not 237. So 252 divided by 47.4, it gives me 5.316. So initial velocity v1I is 5.316. That is rounded to, if you want to move this 5.32 meter per second initially, so the final velocity rather than 3.95, it will be 5. So this is all about our lesson about elastic collision and inelastic collision. There are many examples that we can do, but these were the simplest example that I can talk about. Before I finish my lesson, quickly I will have a recap that collision is two objects hitting together. If their momentum and kinetic energy is both same after and before, it is called elastic collision. If momentum is same but kinetic energy is lost or it converted to some other form, so you can say momentum before and after is same, kinetic energy is not same, it is inelastic collision. And if the object after hitting each other, they stick together and they move together with one system after forming one system after collision, and energy is still lost, this is perfectly inelastic collision. Thank you so much, guys. Hope you guys understood it well. Bye bye.